Ionic bonds. It's a complex jumble of charges and electrons and compounds and a bunch of other stuff. It's a difficult concept to wrap your head around. Before we get into the mind-boggling stuff, let's first establish what an ion is.
An ion is any element particle with a charge. This refers to both positive or negative charges. Positive ions are referred to cations, while negative ions are called anions. When a cation and an anion are combined and one is a metal while the other is non-metal, they create something called an ionic bond, which results to the creation of an ionic compound. But how do you get cations and anions when all elements are neutrally charged because they have the same number of protons and electrons?
They can't just magically turn into cations and anions. If they want to bond, they have to change their charge somehow. They do this by exchanging the number of electrons they both have to break their neutral charge.
When sodium and chlorine exchange, they exchange their number of electrons so that they each would have the same number of electrons as the noble gas they are closest to on the periodic table. If we look at the periodic table, we can see that sodium is the closest to the noble gas neon.
Chlorine is closest to the noble gas argon. Because sodium has 11 electrons, it has to get rid of electrons in order to match the number of electrons neon has, which is 10. Chlorine has 17 electrons, while argon has 18, meaning that they need another electron to match.
Because sodium needs to lose one and chlorine needs to gain one, sodium donates one of its electrons to chlorine when bonding. Losing an electron makes sodium a positive charge or cation, while gaining an electron makes chlorine a negative charge, an anion. Just a reminder, metals like sodium lose electrons while non-metals like chlorine gain electrons.
Congrats! They are now official. Chlorine, you may kiss the bride. And ta-da! The birth of an ionic compound. Sodium chloride!
When bonding two ions, it's important to remember that although the ions individually have charges, the compound they create should be neutral. This means that the charge of a cation has to be equal to the charge of the anion. Confused? Don't worry. Let's look at an example. Here's magnesium and fluorine. Magnesium has a positive 2 charge, while fluorine has a negative 1 charge. When these two bond, the ionic compound they produce does not have a neutral charge because the positive and negative charge don't cancel each other out. The compound would be positive charge because there is not enough negative charge to cancel out the positive. It needs one more negative charge.
In order to have two negative charges, you have to add another chlorine to the mix. Ta-da! Now there's two positive charges and two negative charges, which means that they will cancel each other out, and voila! A neutral ionic compound is formed, magnesium chloride. So yes, you can increase the quantity of cations or anions in order to have the charge of the compound to be neutral.
Sometimes when bonding ions, it's hard to determine the charge transition metals have. Oftentimes, Roman numerals are used to help indicate the amount of charge it has. But there are 3 transition metals that will always remain the same. These metals are silver with a positive 1 charge, zinc with a positive 2 charge, and aluminum with a positive 3 charge. Metals that are not transition metals, which includes metals in group 1 and group 2, will always have the same charge. Metals in group 1 have a positive 1 charge, while metals in the group 2 have a positive 2 charge.
Well, hopefully now you understand ions and ionic bonds, or at least learn something.
Hope you liked the video and see you in the distant future.